Hi, everybody. My name is Guille Amaral, and I work for Aucerna, previously Palantir Solutions. But turns out that it wasn't me who changed, the company changed. So, well, and the name of the talk is Probabilistic Modeling APIs, but it's kind of incorrect because though there is a probabilistic modeling API, it's just one. However, APIs reveals that we were working in this project in many different APIs. So we work for this product, PetroVR, who, for those of you who don't know, is essentially a software for simulating projects of oil and gas industry, long-term, middle-term projects like 20 years or more, 50 years. And it allows the users to model oil and gas operations and then run a simulation, deterministic simulation, event-driven simulation, including a daily routine of fluids, uh, I don't know, realization of the jobs in a scheduling manner. And after that, provided the users associate probability distribution with some inputs allows to run Monte Carlo simulation, right? And then extract results from that, statistical results, and so on. Many different tools like scenarios. I'm not going into detail. Last year, I presented this project in which we've been working, and it's kind of finished. However, there's a lot of work to do in that. The goal back then was to push PetroVR and simulation engine towards the cloud, so the users might be able to consume this API and run multiple simulations at the same time by exploiting the power of a server, right? So, but these simulations were kind of PetroVR simulations, specific oil and gas simulations, both deterministic and stochastic. But then after we finished that, we started to ask ourselves about how other components or more general stuff existing in PetroVR could we expose. In this sense, we kind of see PetroVR as a big, huge corpus or knowledge base. Of course, it's written in Smalltalk, so it is computable, but it happens that there are many layers, like components, thin slices, that can be exposed and that could be, like I said, of a more general purpose, right? And the point here is that we know they work well together. Like these components, these different parts of the system, were extensively developed by specialists in each area. Like, and it covers many different areas that go from mathematics, probability theory, decision theory, optimization techniques, simulation, etc. So, for instance, the first part that we saw that could be a good idea to have it exposed was the unit subsystem of PetroVR. This system possesses these four principles, which are not just features, because when you start dealing with units, you need to provide them, right? So, for instance, it should be a consistent system, or dimensional analysis is a must, provided the user has a way to express a formula with units. Well, this system should provide dimensional analysis, unit inference, And of course, it should be extendable, right? Or extensible. Dynamically added types is corresponds to the types that are produced when a calculation is done by um, combining the units of the calculation, right? So what we did was to create an API with these three entry points. This is a prototype version of this API. These APIs are kind of RESTful APIs. However, we don't meet some recommendations. We were discussing with Gabby about the ATO's stuff. However, this is kind of new for most of the team, so we are learning while we are progressing with this project. Um, what else? Well, distributions is an extensively developed area of the system, and it offers many things, such as many different types and families of distributions. Um, um, the thing is that I, I guess this framework, the root of this framework goes back to the Blue Book, Smalltalk Blue Book, in which there was a design of probability distributions, but it was again developed throughout more than 15 years, so it's kind of very complete. So again, we did an API, which is this, in which, the consumer can know the distribution types, can validate distributions. There is an underlying subsystem of strong validation, so each object in the system is validated, so we can kind of translate the result of that validation in case there is a failure into some HTTP error honoring the recommendations. So, for instance, given a distribution, we can obtain samples of that distribution or the points of the cumulative distribution function or the density function as well. We will see an example in a while. Another part related to the distributions is the correlations. Here we have some heuristics for making two or more samples honor some correlation matrix. So, for instance, simulated annealing is one of the stuff used there. So again, this is as simple as just this entry point, correlations. Uh, how it works, provided a set of samples of course, the same size and a correlation matrix. This entry point will return the samples order in a way that they honor the correlation matrix. So this is another very important subsystem, which is a kind of language to allow users to express formulas. And again, this is the characteristics. So, for instance, it validates several things. It allows, together with a unit subsystem, to infer the unit of constants within formulas. And then it has these two other tools, which are very interesting simplifications. That's it. That's given a formula. It applies different rules for simplifying it, and like for instance, cancel out factors and those things. And disentangler is another useful tool that, given a bunch of formulas, it kind of detects common parts and factor them out into new formulas. So again, this is repeated. We made this API. I forgot to say that there are a list of built-in functions that the user can use within a given formula. So we expose them through these functions entry point. There are many, like from different types: mathematical, Boolean, dates, text, and of course, evaluation is the other entry point, which is important. This allows to provide it a context to evaluate a formula. We will see an example in a second. And finally, stochastic simulation, right? Monte Carlo simulation, which there are more characteristics. I just name a few. It allows to run Monte Carlo simulation in a distributed architecture, like exploiting the multiple cores of the machine, or even we previously we did something that uses like a grid of machines, and it allows after running some sort of clustering of the iterations of the simulation. So let me show you. This is a sample page I made. It's just a catalog of the all these APIs. And for instance, if we go to the units, here we can see the list of the units of a given type. This is just a sample page consuming the units API, right? So for instance, if I change here the type, area, we got the area units existing in the system. And most of them are marked with system, that they are like predefined units. And we can extend this. For instance, we can add a new area. I don't know. Well, it's kind of not working. Well, anyway. And make some conversions, as I said before, like 33 square feet to square kilometers. Just a sample. Going to FML, FML is the one that allows to validate, simplify, and evaluate expressions. This is, again, a sample page. I use Code Mirror for this panel here. And I have here entered this formula as the default formula. And for instance, if I click here, simplify, it sends the formula to the server, and then the server returns this simplified version of the. I'm sorry. So we had A plus 2 times A. Well, the server returned 3 times A plus B, right? And of course, evaluation, like 2 values here. And we have the result. Or for instance, if we put here something with units, like 1 meter. Meters. By the way, that list is the list of built-in functions. I just put them all in this list. And if I evaluate this, I validate first the formula, and I evaluate this, and tells me 200 square meters, right? So there is a unit inference and analysis there. So probability distributions. Again, this is a sample page. Consuming this API, we can see like the request if you want. But I here have the list of available, not all the available distributions, because some of them have some tricky parts in order to instantiate them. But we exposed these families, like for instance, a log normal distribution, and then I can enter here, I don't know, one value, and here, in each of these sample pages, we expose the validation failure coming from the server when some of the parameters of the object we want to create are wrong. Like, for instance, let me enter. So, for instance, if I enter log normal cannot have zero mean, right? Or a negative standard deviation. So again, I have these kind of messages, which are, by the way, the ones that PetroVR uses for the desktop version of the software, right? So, well, different types of distributions, and there you can see the moments of the distributions like kurtosis, skewness, so on. Well, this is the probability API, and even more interesting API is this, where given a probability distribution, you can get a sample of that distribution. So this involves internally a random number generator. So you will see that here I have the seed, right? This is the initial seed for the random number generator that this API will use. So for instance, if I want to generate 1,000 elements, or yes, coming from triangular distribution, if it is working, there is a hell there. Yeah, but this is not. Let me refresh. Oh, well, took a little bit longer than it takes, but let's try again with a normal distribution. Weird. No, this is an old health. No, there you go. I don't know. It's not that hard. Okay, well, let me hide this annoying cloud of points. We are using here high charts as the tool for making these graphs. And where you can see here is the histogram of a normal distribution with those parameters here in a sample of 1,000, right? And a box plot there too. Okay, well, sampling. The other API was the one of correlations. This is a Pearson correlation. And well, here in this, again, sample page, I feel like my presentation is kind of repeated phrases. But anyway, here I have the idea here is that given two samples of a given size and a coefficient of correlation, this API will try to reorder one of the samples in order to honor this correlation, right? Two or more. But in this sample page, I just consume the API in the simplest way possible. Right, so for instance, I generate a sample of, let's say, 15 elements of uniform distribution. So I got this sample and another sample of 50 points of, let's say, log normal distributions. then I have here this two samples, and I will enter here, for instance, minus dot 5, whatever, and try to make them to honor this correlation. It's not so good, but the thing is that the server, in this case, try to make the best for, let's see, this is the trend line. So it's kind of weird, but should be a little bit better. However, the idea is that, right? We'll can check numbers later. And finally, we are getting to the title of the presentation. We had these probabilistic models entry point. You see that the base UV contains PetroVR because, well, weird things that I've been doing before the presentation. But I have here a model, probabilistic model. The basic notion of a probabilistic model, which is a bunch of variables, some of them, of course, with the distributions associated, some calculations in some observables, meaning that the variables that I am interested in knowing their distribution, right? So, for instance, I name it ESUG, and I this probably doesn't make any sense at all, but I created an attendees variable. Variables can be number, date, Boolean, strings, variables, or even calculations, right? And the units API is also present here because any variable can have one of the many different units of that we have. And I set this distribution, I don't know, a log normal with a mean of 150 and a standard deviation of 20 attendees to this variable, right? And then I created another variable indicating the percentage of the volunteers within the attendees. Like, I wanted to relate those variables. And finally, I created this formula, this calculation that relates the two variables, right? So the attendees times or multiplied by percentage of volunteers. So then I can run a simulation, a Monte Carlo simulation of these, let's say 100 iterations, and we'll cross the fingers because this is a demo and it is meant to fail. So, well, I am running the server in the same machine, in a local machine. I try to make it run in a Docker container. So probably I mess up with the things. It's taking a little bit longer than it takes usually. Come on. Almost done. Sorry? A joke? I know. I only know jokes in Spanish, and translating them. But if you have one, you can. I'm sorry? The shampoo? No. Not appropriate for this kind of scenario. Okay, 99. Well, the page is kind of slow. I don't know why. But the thing is that, well, that's the okay. a sample distribution of the volunteers variable, where we can, for in this case, that roughly 10 volunteers. I mean, having 10 volunteers in a year is equivalent. The probability of having 10 volunteers is roughly a half, right? And again, some graphs. This is too slow. And some indicators of this sample, right? Because we have here 100 occurrences of these variable, right, values. So we have moments, we have the mean, the max, and statistic analysis. So let me go back to the presentation. I guess I have minutes left. And okay, this is the API. Probabilistic models allows to create models, and MC is the Monte Carlo where the user can simulate a given model and then retrieve results back from that entry point. And now, just a final thought about this project, which I insist is in progress project. We see it in this way. Usually one has to deal with separated things like components and tools and fight. One fights to integrate them in a as smooth as possible so they behave well together, right? And I'm not complaining. I've been in many different projects in which we try to do this, but in this case, we are kind of are going the other way around. Like we have the whole thing working, and I insist it's tested, used, it works well. The simplicity is like the accent of the company, at least until today. The point is that we have this doing very well, and we are kind of splitting it out into many different pieces that, of course, they are composable. User might want to consume units and other API, but we have the proof that those two APIs will be working correctly inside the server, because they kind of were born like that. So that's it. If you have any question.
Sorry, can you share some of the reflection on what you were talking about with Gabriel, or maybe are you trying to change the app in the future in another way? Use RPC, JSON RPC API maybe, or something else?
Yes, we are like going around the same ideas, because some of these APIs are naturally more suitable for being RPC. We have discussed with him. However, we someday said, well, we want these APIs to be all RESTful. But what is RESTful? I mean, I still don't know what is a RESTful API. I perhaps have to talk more to Gabi, but there are some things that we try to honor. HTOS is something that we are not finding useful for our, because this is, by the way, this is an internal project, right? So the rest of the principles, I think, except for those two, I mean, HTOs and content negotiation, I think we honor.
Not to go in that way, but maybe JSON RPC is good for some of the
yes. That's exactly what I've been discussing with Gavin.
Thanks.
RPC is another option.
Okay, thank you.
Thank you very much.